Hi everyone, in this video we're going to talk about BinSearch. This is a binary search algorithm and it's on page 304 of the textbook, and it is a recursive version of the binary search. Okay, so we want to evaluate BinSearch parentheses 21, x, 1, 10. So let's take a look at what each of those input arguments really are. So the first input argument is t, and in this particular call to BinSearch, t is equal to 21. So when you look on page 304, you can go through the algorithm in any place where you saw t, replace it with a 21, because t is not going to change in this algorithm. T is fixed, t is 21. That is the target item that we're looking for, we're searching for in this very long list called x. And you can imagine you might have a list of, maybe users of Facebook, and you're looking for a particular person in that list, or suspects for a crime or something like that. So you're really just searching for that target, and our target is t equals 21. The list that we're searching in is x, and that's given right here. These last two numbers, those are L and R for the left hand and the right hand endpoints in the indices. So we're only going to be looking, at least to start here, between L equals 1 and 10, so between the first and the 10th position in the list. All right, so let's get started. When we call this function, we'll say BinSearch 21x 110. When we get started here, L equals 1 and R equals 10. And those are just given right there as those last two numbers. I is something we have to compute. So when we compute I, this is the notation for the floor function. So what we'll do here is we'll do the fraction 1 plus 10 over 2. So that's 11 over 2, and then we have to take the floor of that. Okay, so 11 over 2 is 5.5, and the floor of that, the integer that sits right below that number, is, or equal to that number, is 5. So I equals 5. And so now what sorts of comparisons are we going to be making? So let's go through here. If 21 equals x sub I, now we know I is 5, so let's go and find x sub I. 1, 2, 3, 4, 5. So right here is the fifth term. So we're going to be comparing 21 equals 15. No, that's not true. So we'll hop down to the else statement. If 21 is less than 15, all right, there's a comparison that we just made. We're asking, is 21, and I'll put some question marks in there, is 21 less than 15? No, it's not, so we don't even do anything else on that line. We'll go down to this else statement if 21 is greater than 15, so that's another comparison that we'll make. Is 21 greater than 15? And it sure is. And is I less than R? So is 5 less than 10? Now we could put that in here. I don't think they asked for it in the question. I'll write it down just for fun. So we're asking, is 5 less than R? And it is. So now we return BinSearch 21x. Let's start there. BinSearch 21x. I plus 1. I was 5, so now the I is going to be cranked up a notch, so that's 6. And the last number we need is R, and R is currently set to 10. Okay, so now we'll run BinSearch with this new call function. Going in here, we've got L equals 6, that's the second to last number. R is 10, that's our last number. And I, we need to compute what is that. So let's go back to a computation for I. So computing I, we've got the floor function of 6 plus 10 over 2, that's 16 over 2, that's 8. So I equals 8. Okay, let's go through. So let's see, if 21 equals x sub 8, well, let's go find the 8th term. 1, 2, 3, 4, 5, 6, 7, 8. We're looking at the 24 right here. That's our 8th term. And so we're asking, is 21 equal to 24? No, it's not. So we'll down here onto the else statement, is 21 less than 24? Let's write that down. So we're going to ask ourselves about that. Is 21 less than 24? The answer is yes. So let's keep evaluating this line. L less than I. Is L less than I? Looking here, yes, 6 is less than 10, so I could write that down. Now, they didn't ask us to do that in the WebAssign problem, but I feel like writing it down just so I can keep track of where I'm at. So this is true, so if all of that, then return BinSearch 21x Li minus 1. Okay, let's write that down. BinSearch 21x, L is currently 6, and I minus 1, so that'll be 7. So going through this again, L is 6, R is 7, right, because that's the last number in the call for BinSearch, and that we have to compute I. So we've got 13 over 2, that's 6.5, and the floor of that is 6. All right, so we go down through. If 21 equals x sub 6, all right, let's see what we got here. 1, 2, 3, 4, 5, 6. I'm right here on the 18, so that's not true. We'll hop into the else statement. If 21 is less than 18, that's not true. I'm not going to evaluate anything else on that line. I'm going to hop down here, else if 21 is greater than 18. So we've got that going on. 21, is that greater than 18? Okay, let's keep evaluating. And I less than R. That is true because I is 6, and that's less than R, which is currently 7. So then we'll return the BinSearch 21 x I plus 1. So I is currently set at 6, so we'll crank that up a notch, make that 7. And then we have to return R, which is also 7. One last lap through. L equals 7. That's our second to last number in the call for BinSearch. The very last number there is R, which is 7. I, let's see, that would be the floor function of 14 over 2, which is 7. And let's go through and see what happens. So if 21 equals x sub 7, all right, let's count 7 numbers in. 1, 2, 3, 4, 5, 6, 7, and actually we found our target. So at this point we return true. So it's not really comparison, I'll just say we return true at this point, and we're done.